welcome to Los Angeles Data Platform. Today we have a session, Dr. DMV's Troubleshooting Toolkit by Glenn Berry. Glenn, thanks for committing your precious time to deliver a session at our user group. Our sponsor is Data Driven Technologies, which is a nonprofit that funds this event as well as SQL Server in Los Angeles. My name is Steve, and Glenn, it's all yours.
All right, great. Let me see if I can
stop presenting.
So can you see my deck there?
Yep, PowerPoint.
All right. Okay, great. So this is Dr. DMV's Troubleshooting Toolkit, and I'm Glenn Berry, a services database engineer, and I work for a company called Kerber Supply Chain Software. This is my Yay Me slide. And the most important thing about this is my email address. If you have questions that I don't answer during the session, feel free to go ahead and send me an email. And then I'm pretty active on Twitter, Glenn Allen Berry. And Twitter is very important for the SQL Server community. It's a good way to stay in contact with other people. So if you're not on Twitter, that's one reason to be on Twitter. And then I've got a YouTube channel. And also, I know how to brew beer. So I've been brewing beer for nearly 7 years now. And I brew 5-gallon batches with that 3-vessel system there. And it takes about 5 to 6 hours to brew a batch of beer. And then you're drinking it in about 1 to 2 weeks after that. And that's what some of my beer looks like. And then I enter a lot of contests and I've won a few medals. So it's a hobby that I really enjoy. So you probably didn't come here to learn about making beer, but something I could talk about all day. So moving on to the real agenda here. Yes.
Glenn? Can you go back to the first slide, please?
Okay.
Thank you.
All right. All right, so getting back to the agenda here, I'm going to talk about the SQL Server diagnostic queries that I've been working on in the public world since 2009. Talk about the structure of the queries, the history of them, why would you use these? And then the important part of this is I'm going to run through all of them for the SQL Server 2019 version. And as I do that, I'll talk about how to interpret the results. So if you're a database administrator, you know that when your server's not performing well, people tend to notice pretty quickly. And everybody tends to blame the database, and DBA actually stands for default blame acceptor, if you didn't know that. And people always assume that the database is the problem. It's guilty until proven innocent. And sometimes your performance problems are not a database problem. So back when I was working at NewsGator, I got tired of always hearing, what's wrong with the database? Why is the website slow? It must be the database. So I started working on these queries to figure out what is wrong, if anything, with the database. And SQL Server 2005 added DMV queries to the product. It was a huge improvement over the dark ages of SQL Server 2000. And every new version of SQL Server since then has added new DMV queries and added additional columns to existing DMV queries. And these queries also work with Azure SQL Database and Azure SQL Managed Instance. And they give you an incredible amount of information about how your instance is configured, what your workload is doing, what your performance bottlenecks are, and they're incredibly useful. And I use them literally every day now, but I've been using them for years and I update them every month. So the way these are set up, a certain portion of them, about the first half roughly, are instance level queries that apply to the entire SQL Server instance, and it doesn't matter which database you're connected to. And then the ones towards the end of the script are database level, and they're database specific, so you need to make sure you're connected to the database that you care about and not the master database. That's a common mistake that a lot of people make. And the way you run these queries, what I usually do is I run them manually one at a time. And as I'm doing that, I'm collecting the results into an Excel spreadsheet. And I have blank spreadsheets that are labeled to match the queries. And that takes me typically 40 to 45 minutes to do against an instance. But there's also ways to automate it. So dbatools.io has an invoke DBA diagnostic query. They're just made for my queries. and that will let you run them in an automated fashion. But the reason I like to do it manually is as I'm doing it manually, excuse me, I'm getting a good feel for how that database is running. And I'm also making notes and marking up the spreadsheet. And so it's giving me a feel for how the server is running as I'm doing it manually. And you can also run these from a Jupyter Notebook in Azure Data Studio. I've got versions for that too. And I first released these back in April 2009. I update them every single month. And there's separate scripts for every SQL Server version since SQL Server 2005. And it's really important if you're running SQL Server 2012, for example, that you download and use the 2012 version. Otherwise, a lot of the queries aren't going to work if you try to run the SQL Server 2019 version, for example, on 2012. And again, there's separate scripts for Azure SQL Database and for Azure SQL Managed Instance, and you want to download those if you're working with those products. And you might wonder, okay, where do I get these queries? Well, they're on my blog and they're free. I'm not trying to sell you anything. I don't collect your email address. Just go download them. And there's, the full URL to where you get them, and then the bit.ly shortened URL. And this deck will be available after the session. So that's, the first question that usually comes up after you see these. So now that's it for the PowerPoint. I didn't want to waste a whole lot of time on PowerPoint. I want to get to the demos as quickly as possible. So here is SQL Server Management Studio, and I've got SQL Server 2019 version of these. And so I've got a lot of comments and links inside of this script. And it shows that I last modified these today. And I've got a link to where you get them right there. And I even have a YouTube video that's going to be very similar to this session that's already out there that goes through a version of these queries from a few months ago. And then here's the link to the DBA tools site. And then here's the actual method that you can run if you're using DBA tools to run these in an automated fashion. So if I scroll down a little bit more, the first query in the set is just checking to make sure that you're really running on SQL Server 2019. So, because people are always downloading the wrong version and then they complain, oh, it doesn't work. So this is trying to check for that. So I'm going to skip that because I know I'm running on 2019. So then what you'll notice here is each one of these queries has sort of a short description of what it's doing, and then a query number, and then a query name, and then there's 6 dashes after the end of the query. And the reason I've got it set up this way is that there's lots of people around the world who have written code to parse and run these queries, including DBA tools. So I've got it set this way to make it easier for them, and I don't break that, so I don't break all their code. So what you do is just, highlight the first query and go ahead and run it just like you would run any other query in Management Studio. And this comes back with the results for this query. And this first query picks up the name of your instance. So this is a named instance on my desktop here. And then it tells you the SQL Server and operating system version, including, what CU you're on and what build number and the fact that it's 64-bit and it's developer edition. And if you look further over, it's on Windows 10 Professional. So that's useful information that I want to know when I'm starting to look at a server. And just stepping back for a second, you might think, well, why are you running these queries? What's the point here? Well, imagine you just started at a new job and there's a whole bunch of strange database servers that somebody else set up, and you have no idea what's going on with them. So if you run this on an instance, by the time you're done, you're going to have a very good idea what's going on with that server, whether it's configured correctly, whether it has performance issues. And it's the same thing if you're a consultant or just looking at somebody else's servers. It's really, really useful for that. So underneath all these queries, I've got lots of comments and links that help you interpret the results. So down here, it says that the very latest CU for 2019 is CU 13, and it came out on October 5th. And here's a link to download the CU. And then I have a bunch of other links here that are sort of related to this. So where you can download the latest version of Management Studio and Azure Data Studio, for example. So that's the first query. So then the next one is looking at the SQL Server Error Log, and it's going to pick up the core count for licensing purposes. And so I've got a Ryzen 9 5950X processor here. So it's one socket with 16 physical cores, and then it's got SMTP on top of that. So I've got 32 logical processors, and SQL Server is using all 32 of them. And this is really important on a real database server, because if somebody has SQL Server Standard Edition and they install it on a machine, whether it's a VM or a physical bare metal machine that has more cores than it's allowed to use, it'll show up here. So maybe your machine has 32 physical cores and Standard Edition only can use 24 of them. You'll see that here. Now, one caveat with this is if you recycle your error log, this will come back empty because it just looks at the most recent error, excuse me, the most recent error log. So that's one thing to keep in mind there. All right, the next one is server properties, and it just calls server property with a bunch of different input parameters to pull back some useful information about your instance. So this tells me the name of my machine. Here's the name of the instance, and it's not clustered. It's not on a failover cluster instance. It's developer edition, and you can scroll over and see a lot of stuff right here. So it tells you the collation and whether or not full text search is installed, whether file stream is configured, whether you've got availability groups configured at the instance level. Here's your default data path and log path, and here's where the error log lives. So a lot of good information about this instance. All right, moving along to the next one. And also you'll notice here that I have links to things like, here's a link to books online for the server property function, if you're curious about how that works. So the next one is looking at configuration values for the instance. And when I run this is going to pull back 85 rows for SQL Server 2019 of instance level configuration settings. And there's only a few of these that I usually key in on. So I always want to know what's going on with backup checksum default. I think that should always be enabled. Backup compression default should usually be enabled. There's very few cases where you might want to use that. Another one I want to know about is the CLR enabled or not? I want to know what the cost threshold for parallelism is. The default value is 5, and usually that's too low for a lot of OLTP workloads. Another one I want to know about is max degree of parallelism. And then the next one I'm really curious about is max server memory. What is that set to? And then optimize for ad hoc workloads. I think that should always be enabled. I really can't think of a reason not to enable it. And then remote admin connections is another good one to have enabled on a real database server. So those are some of the ones that I think are most important. And I've got comments here that talk about some of these. All right, the next one is DBCC trace status. And this is not a DMV query, but it's just a way of finding out what global trace flags are enabled for this instance. So I've got two here, 3226 and 7745. And right here, I explain what those two are. 3226 just disables logging successful database backup messages to the error log. And I think that you should turn that on, because otherwise, if you've got a lot of databases, you're going to have lots and lots of messages in the error log about every single successful database backup, full backups and log backups. And your error log is going to be harder to look for real important errors. And then 7745 is just a thing that makes Query Store safer to use. So it doesn't write everything to disk before it shuts down or fails over. And that can be a big deal on some workloads that are using Query Store. So I think those two should always be turned on for 2019. All right, the next one is process memory. And this shows you how much memory is SQL Server actually using. And you can't believe Task Manager. Task Manager lies to you. This is the truth. So I'm using almost 47 gigs of RAM right now. And then this next column, lock pages allocation, if that's above 0, that tells me that lock pages in memory is enabled, which I think is a good idea on a production database server. So those are the two most important columns right there. The next one in this set is SQL Server Services information. And this is going to show me what's going on with the database engine service and the data and SQL Server agent. And if full text is running, it'll also show up here. But this tells me the process ID, the startup type, the fact that it's running. And then this is the important one right here, the last startup time. That's really important to know because you need to know that when you interpret a lot of the subsequent query results. It makes a big difference if you've been running just for a few hours or a few days versus weeks or months. And then it tells you what the service account is and whether or not this is a failover cluster instance. And if it was, it would tell you the node name that you're running on. And then right here, this is also important, instant file initialization. I think that should always be turned on. With SQL Server 2016 and newer, you can have it turned on. You can check a checkbox when you install it, but if you forgot to do that, you can go into Group Policy Editor and enable that. But it's really important for performance. And the reason it's not on by default is there's a tiny, tiny security risk associated with that, but you'd have to be doing a whole bunch of dumb things for that to actually be an issue. All right, the next one in the set, this is something I just recently enhanced. This is the last backup information for all your databases on the instance. So it shows you all the databases, the recovery model, and their log reused weight description, which is very important to know. And then here's when the last full backup was, and the last differential, and the last log. And I just recently added this, the last good check DB for all these databases. So this is something you should be checking fairly regularly, because if you're not running log backups, for example, and you're in full recovery model, you've got a runaway transaction log, and you're going to have problems sooner or later. And this will tell you whether you've been running CheckDB, which is something you should be doing on a fairly regular basis. All right, the next one in the set is SQL Server agent jobs. And I've also recently enhanced this one. Since I've been working at Kerber, I've been making a lot of improvements to these queries. So when I run this tells me all my agent jobs, the name and the description and the category and the job owner, which should be SA, I believe. And then here's the last duration. So the last time that I did a full database backup, it took 3 minutes and 4 seconds because my machine is so fast. But I've got this sorted by last duration. So the agent jobs that are taking the longest will be at the top. So this is a nice way to check on your agent jobs. Okay, the next one in the set is SQL Server agent alerts. And those are different from agent jobs, and they're different from notifications of agent jobs failing. You can create alerts. So if certain bad things are happening to your SQL Server instance, rather than just having it go to the error log, it'll fire an alert, and then you can have code that responds to that. And you can also send a notification out to an email distribution list, for example. So rather than trying to find it in the error log the next day, you find out immediately that this terrible thing happened to SQL Server. And the only thing that's ever happened to me is I had a SEB 21 error back on June 25th for some reason. But on a real production database server, you'll probably get more than this. So it's a good early warning system of bad things happening. All right, the next one in the set is host information. And ever since SQL Server 2017, you can be running on Linux or Windows. So this will tell you about your host information. So I'm running on Windows, Windows 10 Pro, and then this tells me that it's US English and it's 64-bit. And this host SKU 48, if I go back to here, tells me it's Windows 10 Professional Edition. So that's nice to know what OS you're running on. All right, the next one on the set is SQL Server NUMA information. And NUMA stands for non-uniform memory access. And this is going to show me what's going on with my NUMA nodes. And since I've got so many cores on my machine here, soft NUMA has split this into 2 soft NUMA nodes. And so they've both got 16 schedulers here, and that's what you want to see. And this is really important when you're setting up a VM in particular, because sometimes people will do weird things with how they set their VMs up, And especially if you install SQL Server on standard edition and you exceed the license core count limit, you can come into this query and you might see 24 cores on one NUMA node and 0 on the other one, for example. And this would help you spot that problem. All right, the next one in the set here is system memory. And this is memory from the operating system's point of view. So when I run this, this tells me I've got 64 gigs in my desktop here, and here's how much is available. And then over here, this system memory state. This is really, really important. This is a flag that the operating system sets. And if the operating system is low on memory, instead of available physical memory is high, it'll say that it's low or steady or transitioning, and that's really bad. And when this flag is set, all the services and applications on that machine are supposed to release some memory. And if you have locked pages and memory enabled, SQL Server can't do that. So it's important that you have max server memory set low enough so that you never starve the OS for memory. And if you see this, anything but available physical memory is high, that means you're under what's called external memory pressure. The OS is unhappy, even though SQL Server might be happy. So you want to do something about that so you don't have the OS lock up, and crash. Okay, the next several queries you can skip if you don't have a clustered instance, a failover cluster instance, or availability groups. And I don't have that here, but if I did have a failover cluster instance, this would tell me about all the nodes and which node owned the instance right now. And then the next one in this set, if I had an AG cluster, it would tell me about that, what the cluster name was and the quorum type and the state of the quorum. And then if I had AGs, this query right here would tell me what was going on with the AG at a high level as far as whether it was in sync or not and what the send rate was and all that good stuff. So I'm going to skip all those for now, but if you have those, they're pretty useful. So the next one on the set is hardware information. And this is going to tell me quite a bit of useful information about my hardware. So it tells me I've got 32 logical CPUs, 32 schedulers, 16 physical cores, not where you have to license for, and how many cores per socket, what my NUMA node count is, how much RAM I have. It tells me that processor affinity is set to auto, the SQL Server start time, how many hours I've been running. This virtual machine type, that one can fool you because if you have a hypervisor running and you're not actually even running inside of it, it'll say hypervisor. So that if it says hypervisor, that doesn't necessarily mean you're running virtualized. Usually it does, but that can fool you. And then it tells me that I've got locked pages and memory enabled. If I didn't, it would say conventional right here. And then it's telling me I'm not running in a container. That's a new thing they added for 2019. If I was running a container, it would show up there. All right, moving on here. The next one in the set, this is how you tell for sure if you're virtualized or not. So this is reading from the error log. It's going to pick up the manufacturer of your server. And in my case, my workstation I built from parts. So it's running a Gigabyte B550 Aorus Master motherboard. But if it was a real server like a Dell or a Lenovo or something, it would tell you the name and model of your server. And if you're running virtualized, it'll say VMware or whatever the case may be for your hypervisor. So that's how you know for sure you're running virtualized. Now, if you're not running virtualized, if it's bare metal machine, this will tell you the date of your main system BIOS. So I'm pretty up to date here, but what I find in real life on a lot of bare metal servers, nobody ever goes in and updates the BIOS. And that's really important to do, but people neglect that, and you can spot that very easily. So the next one is what kind of processor am I running on? And this is incredibly important for SQL Server performance and licensing purposes. So I've got a Ryzen 9 5950X, pretty nice desktop processor, but this would tell you, whatever the model of the processor is, whether it's Intel or AMD, you'll know. And if you're a big hardware geek like I am, you'll know right off the bat, oh, that's a good processor, or no, that's a bad processor. But if you don't know, you can just take whatever comes back here and Google it and find out more information about that. And it's huge because if you're running on an old, slow processor, you're going to see much worse performance than you otherwise would. And maybe you're using more SQL Server licenses than you need to because of that. And it's something, if you're a DBA, you can be complaining about. If you're running on, a 3 or 4 year old processor that was slow when it was new, that's going to be a big part of your performance problems. So, and it really frustrates me. I'll go up to some DBA and say, what kind of processor do you have in your main mission critical database server? And they'll be like, I don't know. I think it's a Xeon. And there's no excuse for that. You should know what kind of processors you're running on exactly. So that's my little soapbox about that. But the next one in this set is SQL Server memory dumps. If SQL Server is unhappy to the point where it almost crashes, and sometimes it actually will crash, it'll generate a memory dump. And this tells you where the memory dump went. And you can submit a memory dump to Microsoft with a support ticket, and they can go in and try to figure out what caused it. And you can also open up a text file. There's 2 text files that get generated along with this binary memory dump that you can sometimes figure out what the problem might be. But if you're getting lots of memory dumps, the first thing you should do is make sure you're fully up to date with your latest service pack and CU. And if you're still getting memory dumps, you should definitely open a support ticket with Microsoft. All right, the next one in the set is suspect pages. And if you have slight problems with corruption that are starting to crop up, they'll get recorded in this suspect pages table in MSDB. And you always want this to come back empty, which I've very rarely ever seen anything come back with this. But if it ever comes back with any rows, it'll have some information about what the problem was. So maybe it was a problem that DBCC was able to fix, for example. So you always want that to come back empty. Now, the next one in this set is something I recently added for 2019, and I'm still kind of messing with it. But this is going to go read all your error logs and come back with the top 1,000 rows. So since I've got 3226 trace flag turned on, this is fairly clean, and it's just showing all these DBC check DBs. But if I had other bad things happening, I could scroll through here and look for things that are bad that were happening that I might want to investigate. So it's kind of nice to be able to get that instead of having to open up in Management Studio. Okay, the next one in the set is how many TempDB data files do I have? So when I run this is running the most recent SQL Server Error Log, and it tells me I've got 8 data files, which is probably about the right amount here. And older versions of SQL Server would just have 1 TempDB data file, but starting with SQL Server 2016, the setup program will look at the machine you're installing it on, and by default, create a more appropriate number of data files. And the reason you care about that is that if you only have 1 data file or 2 data files, and you've got 16 cores, for example, the threads will be fighting over access to those files. It's called allocation contention as objects are being created and destroyed in TempDB. It has nothing to do with disk throughput or latency. It's just an allocation and contention issue. And having multiple database files for TempDB, data files, is really important. And that's something this will help you spot. So the next one in the set is database file names and paths. And this is going to show me how all my database files are laid out across my instance. So it shows you the database name, and then the file ID is 1 is the primary data file, and 2 is the log file. And then here's the physical name. And then it tells you whether it's rows or log. Rows means the data file. And this tells you whether is% growth is turned on. And percent growth is really bad in my opinion. Anything that has % growth on it, you should change it to a fixed size in megabytes rather than being 10%, which is what this means. And then this tells you how big the files are and whether they have unlimited growth or they're limited. So this gives you a high-level overview. I've got an S drive and an L drive and an R drive, and here's all my TempDB files, and I can see how big they are. It's really important for TempDB that they're all the same size. If you have a really large one and a bunch of small ones, the small ones will get ignored because of that, and it'll just use the large file. Okay, the next one in the set is going to show me all the drives, all the LUNs basically that the OS can see, whether or not they have SQL Server database files on them or not. So here's all the drives I have in my workstation and how much space they have available. So that's kind of nice to know. And then the next one shows you all the volumes that have SQL Server database files on them and what's going on with them. So here's the mount point. If I had mount points, they're all in TFS, and the logical volume name, how big they are and how much space they have left, and how much space free percentage-wise they have left, and then a bunch of stuff about whether they support compression or alternate streams. Okay, the next one, this is really important if you're talking to your SAN administrator or your storage administrator, and you think maybe you've got some storage performance problems. This is one way to try to start proving that yes or no. And so this is going to go and roll up all the latency information for all of your drives that have SQL Server database files on them since SQL Server has been running. And since I don't normally do very much with SQL Server on this workstation, my latencies are all 0. They're less than 1 millisecond. But on a real database server, they're usually going to be a little bit higher. But I want to give you a caveat here that this includes everything that ever touches those files. So if you're doing things like backups, index maintenance, running DBCC check DB, all those things are going to go into these latency numbers and make them higher than what you might see looking at perfmon or the SAN administrator dashboard kind of a thing. But this is, if you see high numbers here, and by high, I mean above about 30, 40, 50 milliseconds, then you might want to do some more investigating. But if it comes back and says 50 milliseconds here, don't go screaming at your SAN administrator. You need to gather more information. But this is just one piece of the puzzle. So that's drive level. And then the next one in the set goes into file level. So this goes and does the same exact thing, but it shows you all your database files, and it's sorted by the highest latency. So this will show you, okay, the server monitor database has a log file that has slightly higher latency than all the other ones. And it tells you how big it is and how many reads and writes it's had. And then these far right columns are resource governor. So this would tell you if resource governor was in place, whether or not it was throttling the I/O for that, for example. So this is incredibly useful in real life. But again, the same caveat applies that these latency numbers will be higher than other tools will show. And this is what SQL Server thinks about what's going on. Okay, the next one in the set is looking for 15-second I/O warnings. And this is one your SAN administrator cannot blow this off if this comes back with anything. So when you run this on my machine, it comes back empty. But if you run this on your machine or your database server and you have a whole bunch of 15-second I/O warnings, don't freak out yet. What you want to do is look at what's happening. Is it the same file happening at 3 a.m. every night when you're running DBCC check DB? Well, that means one thing. Or is it lots of different files at different times of the day with no apparent pattern, just lots and lots of 15-second I/O warnings? If that's happening, it is time to freak out because that means you're getting really, really bad storage performance all the time with all the different files. And if you go and show that to your SAN administrator and they try to blow you off, oh, that's no problem, they're wrong. It's really a big problem for SQL Server. So hopefully that never happens to you. Okay, the next one in the set is Resource Governor Resource Pools. And Resource Governor is Enterprise Edition only. And most people, in my experience, are not using it. But if you are using it, you can use it to try to control what resource groups are using as far as memory usage and CPU usage and now IO usage. So if you have like analysts, business analysts that are running ad hoc queries and they like to do select star against a 10 billion row table, you can throttle them so they're not killing your whole server. So that's what it's mainly used for. Okay, the next one in the set is database properties. And this is going to show me a whole bunch of very interesting properties about all the databases on my instance. So here's the database names, and here's the owner, and this is wrong on purpose. You don't want your databases owned by an individual login. They should be owned by SA. And then here's the database compatibility level. And this is really important on modern versions of SQL Server. Back before SQL Server 2014, this was not really that important. All it really controlled was whether certain new features were enabled or not. But ever since SQL Server 2014, this controls things like which cardinality estimator you're using by default and a bunch of other behaviors with SQL Server 2016 and newer. And so this is really important that you know this and you think about, what compatibility level you're on, and you can change it. It's not set in stone. But if you take a SQL Server 2008 database and restore it to SQL Server 2019, it's going to be in 100 compatibility level unless you change it. And if you leave it that way, that can have big, big effects on performance. So you need to understand how that works. And that's kind of out of scope for this talk, but that's something you need to be, keenly aware of. So here's the recovery model and the log reuse weight description and what's going on with your log file usage. And then page verify option. This should always, always, always be checksum. Don't have it as torn page or none. And then scrolling over to the right, other things like right here, mixed page allocation. This is something that should be turned on with SQL Server 2016 and newer. And it won't be if you take an old database and restore it to a new version of SQL Server. Another one that I think should be on for most people is auto update stats asynchronous. That's not on by default. Another one that should not be turned on for most people is force parameterization. That's usually a bad thing. Another one you want to look at is, are you using read committed snapshot, RCSI? That can be really useful for solving locking and blocking and deadlock issues, but it puts a load on TempDB. Another one you never want to have turned on is auto close and auto shrink. And then this one right here is also very important, target recovery time in seconds. You want that to be set to a non-zero value on SQL Server 2016 and newer. And you can see it's not on some of these because they were older versions of SQL Server that got restored to this SQL Server 2019 instance, and I haven't bothered to change it yet. But having this turned on lets you use what's called indirect checkpoints in the dirty page manager inside of SQL Server, and this helps even out when SQL Server takes checkpoints, and it makes a lot of things go a lot faster and improves your I/O performance. And so there's more stuff over here. It shows you if you're using change data capture, if you're in a publisher for replication, a lot of things. Right here, group database ID has to do if you're using availability groups. So a lot of good stuff here. And I guarantee you, if you run this on your server at work, you'll find things that are probably wrong that need to be changed. Okay, the next one in the set is missing indexes for all databases by index advantage. And this is really powerful, but it's also really easy to misuse and abuse. And every time that you run a query, the query optimizer, if it doesn't have an index that it thinks it would like to have, it takes note of that and stores it where we can get to it. And if you run this on your server at work, it might come back with hundreds of rows. So the absolute worst thing you could ever do is just go and create 100 new indexes based off of this query. Please don't ever do that. And what this thing is doing is this index advantage column is a calculated figure based on how often it wants that index and how important it is to have the index. and how costly it is not to have it. So it makes a big difference if you've been running just for a few hours or a few days versus weeks or months, because that's going to have an effect on whether this is significant or not. Is 6252 significant? Well, if I've been running for quite a while, probably not. But if I've just been running for a short time, that could be huge. So that's one thing to keep in track of. And then right here, the last user seek. That's really important because if you run this and the last user seek for an index that it's asking for was 2 weeks ago, that means it is probably just some ad hoc query or reporting query that's not run very often. But if you run this and it was just a minute ago or a few seconds ago, and you run it again and it updates, that means that whatever's triggering that is part of your regular workload, and it's important. So that's really important to understand. And then if we scroll over to the right, SQL Server 2019 is great because now I can get the query text. So now I know what query or stored procedure is triggering that request, and that's golden because now I can judge or talk to the developers. Is this important? Do we run this all the time? Are users complaining about this thing being slow? That helps you judge, do you want to create this index or not? Now, the average user impact, that's the percentage that the query optimizer thinks that the cost of the query would be reduced if it had that index. So higher percentage is better. And then average total user cost, excuse me, that is a measure of how expensive it is to not have that index. So if it's a really large table and you're having to do a table scan or a clustered index scan because it doesn't have the index it wants to do a seek, this number will be really large. And then user seeks tells you how many times SQL Server has wanted that index. So higher numbers obviously are more important. So these three numbers together are what get multiplied to create that index advantage thing over on the far left. And then what you want to pay attention to when you're looking at this is that quite often it'll come back and want, say, 10 indexes on one table. But if you look closely, the columns that it wants might be very, very similar, especially for the equality columns and the inequality columns. So what you want to try to do, don't go in and create 10 separate indexes. See if you can combine them into 2 or 3 maybe. And the included columns also are really important. So if you can make one wide index that covers multiple requests, that is really good instead of a bunch of narrow indexes. So that's some of the caveats here. And there's other things you want to look at before you decide to create an index or not. But the one thing I hope you remember, do not run this query and then turn around and let's just create 50 new indexes. That's usually the wrong thing to do. Okay, so moving on, the next one is VLF counts, and VLF stands for virtual log file. And that's every time your log file grows, it adds a certain number of VLFs. And all those VLFs hurt write performance to the log file. That's one problem. And it's not a problem until you get above about 1,000 or so. But the higher the number, the worse the problem. And it also hurts crash recovery. So every time SQL Server starts up, all your databases have to go through crash recovery. And if you've got tens of thousands of VLFs, that takes a lot longer. And it also comes into play if you're restoring a database from backup and you've ever watched it where it says 99% complete, 100% complete, and then it keeps grinding for another 5 minutes after that. Well, it's finished with the restore portion and it's going through the recovery portion at the end. And it takes a lot longer if you've got a high VLF count. And then the other thing that affects, if you've got a traditional failover cluster instance and you fail over to the other node, well, that instance starts up on the new node and all the databases have to go through crash recovery. So if you've got high VLF counts, your failover is going to take a lot longer than it otherwise would. And the way you cure this problem, if you have high VLF counts, is you go in and make sure that your log growth, auto growth is set appropriately, and then you shrink your log file. And that's going to get rid of your VLFs. And you might have to go in and shrink your log file multiple times after you take a transaction log back up to actually get it to shrink. So here's the little formula with SQL Server 2014 for how many VLFs get added based on how big the file growth was. Okay, the next one in the set is showing you which databases on the instance are using the most CPU. And this is looking at all the query plans that are in the plan cache. So this can sometimes give you incorrect information. So if you went in and flushed the plan cache for one database, then the rest of these are going to be wrong, for example. Or if you're under extreme memory pressure and plans are being evicted from the cache because of memory pressure, this will give you incorrect information. But right now it's telling me that this AdventureWorks LT database is using the most CPU. So if I was under CPU pressure, if I looked at Task Manager and my CPUs are running at 95%, then I would run this query, which database is causing the most CPU, right? So what you're trying to do is narrow down the problem. And so many novice DBAs have no idea. They're just guessing. Well, let's try restarting SQL Server and see if that fixes it. Let's try rebuilding all the indexes and see if that fixes it. They're just taking stabs in the dark. Well, if you run these queries, you're not guessing. You're getting closer and closer to the answer of what the problem is. Okay, so that's CPU. And then the next one is I/O usage by database. So which databases are using the most I/O? Now this has the same caveat. This is all the I/O since SQL Server's been running. So this includes backups and index maintenance and DBCC check DB, plus your regular workload. So what you're going to find is that your largest databases tend to drift to the top of this list, but it tells you the total I/O, and then it also breaks it down into read I/O and write I/O. And this is useful because this helps you understand if your storage subsystem is set up correctly. If you know that a particular database is really, really write heavy, you want to make sure you're not using a parity-based RAID level like RAID 5 or RAID 50. For example, it'd be better to be using RAID 10 that doesn't have a big write performance penalty. So this helps you start to understand that stuff instead of just guessing. All right, the last one in the set, this can take a long time to run on a real database server, several minutes sometimes, but it'll be okay on my machine. But even on my machine, it took a little bit, right? And this is measuring which databases are using the most memory in the SQL Server buffer pool. So this no compression test database is using about 19 gigs of RAM in my buffer pool. And then the rest of them are really just tiny there. So if I was under memory pressure, I'd want to start looking at that one. So the next one is looking at version store space usage. So if you ever turn on RCSI for any of your databases, well, what's going to happen is TempDB has a version store that keeps track of what's happening with the data as it's being changed rather than using locking. So this would tell you what's going on with that. So the only thing that's showing up here is MSDB because I don't have RCSI turned on all these databases. Okay, this next one is top weights. And this is another one that people misuse all the time. And what it's doing, it's a huge query here, a lot of stuff in it, but it's looking at the cumulative weight types since SQL Server was last started or since somebody cleared the weight stats with this command right here that I have commented out. So if I go back to the results, it's sorted by weight percentage. And then here's the weight types. And then the average weight in seconds broken down into resource and signal. And then the weight count. And then this is a link to SQL Skills where Paul Randall has been documenting what do these mean? Because what happens, unfortunately, is somebody will run this query and they'll Google CX packet. What is that? What does that mean? And they Google CX packet and they find some old blog post or forum post from 2010 where somebody says, well, if you've got high CX packet weights, you should set your max stop to 1, and that will fix it. Well, yeah, that'll fix it, but that'll disable parallelism. And that's usually the wrong thing to do for most workloads. So what you want to be careful not to do is don't run this query and then Google the weight type and then just do something based on that. That's the wrong thing to do. Paul Randall likes to call that knee-jerk performance tuning. You don't want to do that. All this does is point you in one direction or another to do further research and analysis before you start changing settings based on this. And then the other thing is that if your server is running really well and nobody's complaining, then these aren't as important because SQL Server is always going to be waiting on something. But where this is important is if everybody's complaining, oh, the server's so slow, the website's timing out, we're getting deadlocks, oh my God. And you're on the hot seat. What's wrong? Fix it right now. Well, this can help you figure out what the problem might be. So certain things, will point to a CPU problem or a storage problem or a blocking problem. So that's what you want to get from this query. But don't lose your mind, and start changing things just off of running this query. Okay, the next one is going to show me all my connections by IP address. And since it's just me here, it's not very exciting. So it shows my local connections and then all the SQL stuff that's going on. But on a real database server, this will show you your web servers and app servers and everybody who's connected to it remotely and what their IP address is and what program they're running. So this is pretty useful to understand, is your workload kind of normal or is it really heavy? Or if somebody's saying, hey, the web server can't connect to SQL Server, is SQL Server down and you can run this? Well, no, I see 20 connections from that web server. Maybe your connection string is wrong. So it's good for troubleshooting connectivity. Okay, the next one is really good for a DevOps dashboard kind of a thing. And when I run this is going to show me my average task counts and a bunch of other things. And you want to run that a whole bunch of times like I am here, because on a real live production server, these numbers will be changing. So average task count is the average number of tasks that are on each one of your schedulers. And remember, I've got 32 schedulers. And SQL Server is really not doing anything. It's just me talking. So that's why the average task count is 1. But if it was actually under a regular workload, this might be 5 or something. And if you see the average task count above about 10 to 15, that usually means either your server's just busy, or it could mean you're seeing a whole bunch of blocking and deadlocking. So that's what this tells you right off the bat. And then average runnable task count. A runnable task is a task that is in a runnable state and it's waiting for CPU time. So usually if the average runnable task count is above 0, that's a pretty good indication that you're under CPU pressure. And then the next one is average pending disk I/O count. And if that's above 0, that means you've got tasks that are waiting for disk I/O to complete. So usually that means you're seeing some storage bottlenecks. And this will be, changing from second to second. But if you run this a bunch of times and you see really high numbers for these 3 columns, that means something bad is happening that you need to look into. All right, so if you did see high average task counts, the next one you'd want to run is this query right here that would show you if you've got any blocking going on right now. And of course I don't, but if I ran this, it would show me the lock type and which database and what the waiter is and what the blocker is. And this would help me start to figure out what the problem might be with blocking. Okay, the next one in the set is CPU utilization for the last 256 minutes. And it runs and keeps track of this in the ring buffers DMV, and it only goes back 256 minutes. And it shows you SQL Server process for this SQL Server instance, and then anything else is running on the machine. So I've got PowerPoint and Microsoft Teams and some other things running. So that's why I'm seeing these 8%, 7% for other things running. And if I saw this on a production database server where where the other processes were higher than SQL Server, I'd be mad. I'd be wanting to find out, what is that? Who's using my CPU to do other things? And this is the database engine for this instance. And if you're doing something like running reporting services on the same instance, it'll go into this number. If you're running monitoring software or antivirus software, or somebody's surfing the web, any other thing besides the SQL Server process is going to show up here. And these are just in 1 minute. Every minute it takes a little snapshot and records it here. So if you open up Task Manager and it's pegged at 100%, you could run this and see, has it been pegged for just a couple minutes or the last hour? So that's what this is useful for, assuming that you can't get that some other way. So if you did see that you have been running really hot CPU-wise, this next query is going to tell you who's causing the CPU pressure. This is the top worker time queries for the entire instance, and this is going to pick up ad hoc queries and stored procedures. So when I run this, there's a database called Server Monitor that every minute goes out and collects some SQL Server metrics, and that runs every minute, and it's been running for several days. So that's why it's showing up at the top of the list. And this is telling me what the short query text is. But it sorts by total worker time, and you can see the numbers fall off really quickly. And that's how it's going to be in real life most of the time. So if I was running at 100% CPU and I ran this query, I'd want to look at like the top 3 or top 5 and try to understand, okay, what are they doing that's causing so much CPU pressure? Maybe they have a missing index. Maybe they're doing implicit conversions and they're not using an index. Maybe they're just poorly written queries. So I get all this useful information about the worker time and then the elapsed time. And these elapsed times are in microseconds, not milliseconds. And then the logical reads. And then this right here is golden, has missing index. If you see that as a 1, that means there's a missing index warning for the query plan that thing is using. And when I see that as a DBA, I kind of get all excited because that's something that's easy to fix. And if I can go in and add an appropriate index, I can sometimes, make a query go from, 100 seconds to 100 milliseconds. And if you do that, the people at work are going to think you're a genius. Oh my God, what did he do? It's so much faster now. And it's so simple if you know how to do it, right? So this is like the secret DBA trick is index tuning to get much better performance. So that's going to help you find those guys and fix them. So the next one in the set is page life expectancy for the instance. And this is going to show you your page life expectancy by NUMA node. And page life expectancy is how many seconds does data live in the buffer pool before it gets flushed due to memory pressure. And this is a really high number. And if I run this thing again, it goes up because I'm just sitting here talking and SQL Server's bored. But you want to run this at different times of the day and different days of the week. And hopefully you've got some sort of monitoring software that is checking this so you can watch the trend. But if you see low page life expectancy and it's sustained and getting lower, that means that you're under internal memory pressure. And that's really, really bad for SQL Server. And there's a lot of things you can do to try to fix that. But this is the best way, in my opinion, to spot that. So the next thing, if you think you're under memory pressure, this is a perfmon counter, memory grants pending. And if you run this, this should always, always, always come back 0. If it ever comes back above 0, that's SQL Server screaming bloody murder that it's under memory pressure because it can't get a memory grant to come up with a query plan or execute a query. And that's really, really bad. And it's very unusual to see that. Okay, the next one, memory clerk usage. This tells you what is using your memory. So what you want to be using your memory is memory clerk SQL buffer pool. That's cached data in the SQL Server buffer pool. And that should be your top consumer of memory. But what you'll see a lot of times is this one right here, cache store SQL CP. And that thing might be running, using 8 gigs, 10 gigs, a lot of memory, even on a server with not very much memory. And that's your ad hoc and prepared query plan cache. And there's ways to help solve that I'll talk about in a second. But if you see this as a high value, that's something you want to investigate. So the first thing that you can do to help control that is make sure that optimizer ad hoc workloads is enabled. There's really no reason not to have that enabled, except for a couple minor edge cases. And so have that turned on at the instance level. And then what you're probably going to have to do in real life in most cases is run this command right here, DBCC free system cache SQL plans. And that's going to just flush that ad hoc and prepared cache. And you can do it. I have a lot of customers that just run it every hour on an agent job, or even more often, because they're using so many ad hoc queries. So just doing optimizer ad hoc workloads by itself is not enough. And those two things together will control that problem pretty well. Okay, the next one in the set is if you did see a lot that way, okay, who's doing it? So if I run this query, it's going to show me all my ad hoc queries that have just one use. They'll have been run one time. And each one of these has its own query plan in the plan cache. And you can see the database and what the query text is and how big it is. And I just recently added this. Now I can see if it has a missing index warning. So here's an ad hoc query plan that's only been called once, and it has a missing index warning. And right below it is a similar one. The only difference is probably the parameter value that's embedded here is different. So it's got its own query plan because of that. And that's wasting memory in the plan cache that could be better used to cache data. Okay. The next one is which queries across the entire instance have the most logical reads. And logical reads means that you're finding the data in the plan cache, or not the plan cache, in the buffer pool, rather than having to go out to the storage subsystem. So it's sorted by total logical reads, and you can see that the numbers fall off very quickly. So this guy right here, this store procedure, has the most logical reads, and that's causing memory pressure and indirectly I/O pressure. And if I scroll over to the right, I've got a missing index warning on that guy. So if I was going to look at the query plan, which I could do, by the way, if I wanted to, right here, notice this commented out line. If I uncommented that, it would give me the complete query text plus the graphical execution plan, and I would see the missing index warning. And then I would know what index the query optimizer thinks would fix that problem. So that's really, really useful when you're trying to solve your performance issues. So the next one in the set is the same thing, except it looks for the top average elapsed time queries across the entire instance. And this can take a while to run. On my machine, it came back fairly quickly, but this is showing this guy, and these again are in microseconds, and it's sorted by average elapsed time. So this is 1.1 seconds, for example, and it does not have a missing index warning. So I'd have to actually go in and look at the execution plan and some other things to try to figure out what, if anything, I could do to make that better. Okay, and that's where you can, again, make yourself look like a genius. Because remember, when you're a DBA, most of the time your boss has no idea what you're doing. And you want to get in the habit, if you find a query that's taking 10 seconds to run, and you go in and do your DBA magic, so you want to take some metrics. Okay, it was taking 10.5 seconds before I did this stuff, and now it runs in 200 milliseconds. Well, you want to record the before and after and make sure to tell your boss about it, because usually they don't know what you're doing, and it's not a bad thing to blow your own horn a little bit about that kind of stuff. All right, the next one in the set is looking at UDF stats by database, and UDF stands for user-defined functions. And this is only going to pick up scalar UDFs, which are really, really bad in SQL Server. So if you have any scalar UDFs on the instance, they'll show up here. What the name is and what database they're in and some of their metrics. And most of these are coming from MSDB. They were written by Microsoft, so shame on Microsoft. And here's one in AdventureWorks. And if you have scalar UDFs, you want to try to talk to your developers about not using them. If they're already there, you want to do things like convert them to a table valued function that just returns one row and one column. Or if you have SQL Server 2019, it has a new feature called automatic scalar UDF inlining that works pretty well on a lot of those UDFs. Okay, so that's all the instance level queries. So now it's really important that you switch to a database that you care about. And that's why I said use your database name and commented it out. And you wouldn't believe how many email questions I've got. Well, I don't have a database called your database name. What are you talking about, Glenn? No, this is just to try to remind you to switch to the database that you want rather than master. Because I can't tell you how many people have run these queries and then all their database level queries are hitting master. And usually master is not very interesting. It's whatever main database for your application or the one that's causing the most problems. That's what you want to look at. So once you're sure you're on the right database, then we start running the database level queries. And this is going to tell me, this first one, what's going on with the files in that database. So here's the data file, and here's the log file, and here's where it's located. Here's how large it is, and how much space is actually used, and how much is available, and what file group it is in, whether it's using percent growth, is it read-only, is it the default file group, does it have auto grow for all the files turned on? That's all kind of interesting. But then right here, here's the log file. And notice my log file is about 8 times larger than my data file. And that's usually not a good thing. That means that at one point I had a runaway transaction log and this thing grew and probably has a high VLF count. So I might want to shrink that to get that space back. And it's okay to shrink log files. You don't want to do it every night in an agent job, but if you've noticed that it's really, really big and it doesn't need to be that big, it's no big deal to shrink it. But it's not okay to shrink data files. If you shrink a data file, it's very, very resource intensive and it severely fragments your indexes. And the only time you should ever shrink a data file is if you delete a whole bunch of data and you know it's not coming back and you really need your disk space. And then it's okay to shrink it, but then you're going to need to go in and reorganize or rebuild your indexes at some point to get rid of the fragmentation. So moving on, the next one in the set is log space usage. And this is a new thing that they added in 2016, this DMV. And it lets you see what's happening with your transaction log and how much space you've used since the last log backup. And the reason this is kind of useful is most people go in and set up an agent job to back up their log like every 15 minutes based on their RPO they're trying to achieve, recovery point objective. And what you could do instead, if you wanted to, you could have the agent job call a query like this to figure out how much space has been used since the last log backup. And you might decide, rather than waiting 15 minutes, I could do it now because I've used a whole bunch of space in the last minute, for example. So you could use space-based log backups rather than time-based log backups is what that's useful for. All right, the next one in the set is if you go in and try to shrink your transaction log and it won't shrink, this will tell you why. So when I run this, this tells me this VLF status of 2, that the last VLF in this log file is still active. And I'm not going to be able to shrink the log file probably because of that. So what you want to do to try to fix that is run another transaction log backup. And if that doesn't work, excuse me, what you might want to do is something silly like reorganize an index just to generate some log activity to move the active VLF to a different part of the file. So that'll help you get around that problem, not be able to shrink your log file. Okay, the next one in the set is database scope configurations. And this is a new feature they added in 2016 that they added a whole bunch of new ones to in 2019. But these are things that you can set at the database level that used to be you can only set them at the instance level. So for example, max degree of parallelism. It used to be you could just only set that at the instance level. And that was a big problem. Like if you had a SharePoint database on your instance, well, Microsoft tells you to set your SharePoint databases to max stop 1. So a lot of people were stuck doing that for the entire instance, and that's really bad for most databases. But now you can pick and choose which databases have that value. And the same way for all these other things. And one thing that I like to turn on for most databases is this one right here, Query Optimizer hotfixes. This lets you control, it's the equivalent of trace flag 4199. And if you turn this on, you'll get all the Query Optimizer hotfixes since RTM for whatever version of SQL Server that you're on. So every service pack and every CU, has these Query Optimizer hotfixes that are not enabled unless you turn this on. And usually that helps performance in my experience. Okay, the next one is going to show us IO stats by file for this database. So this is going to help me understand, do I have more of an OLTP workload or more of a reporting workload at the storage level? So it shows me how big the file is and the number of reads, the number of writes, and the megabytes read and written, the percentages. So instead of just guessing, oh, I think this is OLTP, or oh, I think this is a data warehouse, I can have a better idea from a storage perspective what kind of workload I'm seeing. And that helps me decide on things like, should I add more indexes? Should I use data compression? Should I use RAID 10 instead of RAID 5? All those sorts of things. So again, we're trying to figure out the facts here instead of just guessing like so many people do, unfortunately. So the next one is going to show me what queries are executed the most frequently for this database only. So here's the short query text and the execution count and all these other metrics, including the missing index column. And then these two columns are also really important. This tells me when did that plan go into the cache, and here's the last time it was executed. And if you're under severe memory pressure, what's going to happen is your plans, your query plans that are in the plan cache are going to be evicted due to memory pressure. And so instead of having a plan cache time from days or weeks ago, it might be minutes ago. And if you see that, that means the rest of these numbers are more suspect. And ordering them by total logical reads is not going to give you the true answer if the plan cache time is wildly different dates. So that's why these are important to look at. Okay, the next one in the set, these next several queries are what I call the bad man list. And this is something I came up with way back when I was at NewsGator. So I would run these bad man list queries and put them in a spreadsheet in separate tabs and then send them out to all the developers. And the developers, they knew which store procedures that they wrote or last touched. And they didn't want to be at the top of the bad man list. And it wasn't to get them in trouble or shame them. We were working together as a team because this is showing us which store procedures in this database are causing the most pain for SQL Server. And if you collect this and work on it as a team, I guarantee you, you will make things better if you do this the right way. So that's the background behind that. So this is going to show us which store procedures are called the most often. And and usually developers, they love to see this because, they're kind of in an ivory tower writing code, and they may not, unless they're doing DevOps stuff, they're not seeing what's happening out in production. So if you show them, hey, this store procedure is being called a lot, and they might say, well, that doesn't make any sense. And sometimes they'll go back and look at their code and say, hey, wait a minute, I found a problem where we're calling that 3 times in a loop, and I only meant to call it 1 time, for example. So you'll find things like that. And you also, maybe there's something they're pulling back, like get a list of all the states in the United States. Well, that's pretty static information, right? Unless the United States invades Canada, for example, we're not going to have any more states anytime soon. And that's pretty static. And you could probably cache that in the middle tier or on the client instead of calling it, 50 times a second to get static information. So this helps you identify caching opportunities. So that's what that's useful for. Then the next one is sorting by average elapsed time. And this is going to tell you which stored procedures are taking the longest, on average in microseconds. So maybe you can find some low-hanging fruit for tuning. And as you're running these, look at the missing index column, because those are the easy ones. Those are easy wins for a DBA. If there's no missing index, that means you actually have to do a little bit more work by looking at the execution plan and analyzing the T-SQL for bad practices and things like that. But if you find that query that's taking 10 seconds and you make it run in 200 milliseconds, and everybody's going to think you're a wizard, and that's where you find those wizard opportunities. Okay, the next one is looking at total worker time. And worker time is CPU effort. So this is showing you which stored procedures are causing the most pain for your CPU. And if you're running at 100% CPU and you figured out that this is the database that's causing it, and now we know which stored procedure is causing it, and it's got a missing index warning, I'm going to get all excited because, oh yeah, I can fix that. That's going to be easy to fix probably. But this is really, really valuable in real life. Now, the next one is logical reads. So this sorts by total logical reads. And these are what you're finding in the buffer pool. And see how the numbers fall off really quickly? These top two are much, much higher than the rest of them. And they both have missing index warnings. So if I went in and fixed those guys, that's probably going to really have a good effect on my memory situation. Okay, the next one is looking at physical reads. And that means it's having to go out to disk to get the data. And so you want to look for the same pattern, and these two guys are showing up. They're really causing us a lot of pain, those two stored procedures. And then the next one is looking at logical writes. So this is going to show me which stored procedures are causing the most write activity. And you can kind of tell by the names, right? They're all update, update, update. Okay, the next one is looking at all the stored procedures in this database that have missing index warnings for the query plan that's in the plan cache. So all 5 of these have missing index warnings, and here's some of their metrics. So if I came in here and saw the really high average elapsed time or high logical reads, I'd probably want to look at that and see if there's something that I need to fix. Okay, the next one in the set is top IO statements. So among all your stored procedures, which statements within the stored procedure is causing the most IO? So this little select statement right here, which got truncated, is causing 24,000 IOs every time it's called. And that's a lot, by the way. So I want to go in there and look at that and try to figure out it. And I already know by now that there's a missing index that would really help that. So it's having to do a clustered index scan of that table every time. And that's really painful. Okay, the next one in the set is bad NC indexes, non-clustered indexes. And this just means indexes that have more writes than reads. And in this case, I've only got a couple, but I guarantee you in real life, you're probably going to have a whole bunch that have a lot more writes than reads. And what you might find is some indexes that have 0 reads and millions or hundreds of millions of writes. And that's why another reason you really want to know, how long have you been running? Have you just been running for a day or two? Well, if that's the case, I would be really cautious about dropping indexes. But if you've been running for a couple of weeks or long enough that you've seen your complete business process, whatever your applications do, have done everything they're ever going to do, and you run this and you see a bunch of indexes that have lots and lots of writes and 0 or a really low number of reads, then I would think really hard about dropping that index. Now, I don't bother with disabling indexes. What I do in real life is I script out the index and then drop it and then see if the world, falls off the cliff. but I'm usually really careful and I don't get bitten by that. But dropping indexes that are not ever being read from is really good, because then you're getting rid of all that effort to maintain those indexes, and you're freeing up space inside of your data files, and you're making your backups go quicker. Lots of benefits. So then here's the missing index query again, but it's filtered down to this database, and it also shows some more information on the right. So if I scroll over to the right, now I've got the name of the table repeated here, and then how many rows are in the table. And that's really important if you're running on standard edition, because standard edition doesn't have online index operations. And you need to be a lot more careful about creating indexes, because when you create an index, it's going to lock up the table while the index is being built with standard edition. So that's something you have to use your judgment and experience as a DBA. Depends on how fast your storage subsystem is, whether you can build an index on a 20 million row table or not without causing a problem. Because if you're a DBA, you're kind of like Scotty in the engine room of the original Enterprise series. You know, you're doing all this stuff and nobody knows what you're doing. But if all of a sudden the website freezes up for 10 seconds because you locked up a table while you were building an index, that's bad. Nobody should ever know, you know, you're like the magician that does all this stuff. And this helps you avoid people noticing your mistakes. So the next one in the set is looking for missing index warnings in the plan cache for ad hoc queries and stored procedures. And this can take a long time to come back, many minutes on a big database server with a big plan cache. But in this case, it's showing me the name of these stored procedures, and it also pulls back the query plan. And if I click on it, it shows me the graphical execution plan, and here's the missing index warning of the index that it thinks would help this. And just because you see that doesn't mean you're automatically going to do it, but it's claiming that it would reduce the cost of that query by 93%. And it's also claiming that this query cost is 100% of the batch. So usually this is fairly reliable. So if I actually put this index in place and SQL Server decided to use it, this query that's triggering this would come back a lot faster, you know, almost 94% lower cost is what that's claiming. So that's how that works. And that can be really useful. The next one is another query that takes a long time on an instance with a lot of memory. And it might even take some time here, but I don't think so with this database. And it's going to show me which indexes are taking the most space in the buffer pool. So it's on the primary file group, it's DBO schema, the event log table, index ID 1 is the clustered index, and it's taking 186 megabytes of space in the buffer pool, and it's not using any compression. And here's how many rows are in that table. And here's a copy of that, by the way. It's exactly the same as this, but it's using page data compression, and it's only using 43 megabytes. So I'm getting more than a 4-to-1 compression ratio with page data compression, because data compression helps you both on disk and in the buffer pool. It's a really valuable feature that hardly anybody uses, which kind of blows my mind. All right, the next one in the set shows you how big these indexes are on disk. So you can see how big they are on disk, and the fact that these guys are not using any compression. So this also helps you find data compression candidates. And one reason that people don't use data compression is it wasn't in standard edition until SQL Server 2016 SP1. But ever since then, it's in standard edition, and you can use it, and it works really well. All right, the next one in the set is table properties. And we're getting close to being done here. But anyways, this shows you for all the tables, every index and how many rows are in it, and whether or not that index is compressed or not, and then a bunch of other interesting stuff about it, like whether it's replicated, whether it's CDC is being used, you know, whether it's memory optimized, all that good stuff. All right. The next one in the set is looking at statistics. This shows you when your statistics for all the different indexes and statistics in your tables were last updated. And if you've gone in and done something like disabled automatic statistics updates, you will probably run this and see that your statistics are all pretty old. And that can cause a lot of problems because the query optimizer relies on the statistics to come up with a good quality query plan. And this will help you spot problems with that. The next one is called volatile indexes, and this shows you which indexes and statistics have been updated the most. And the reason you care about this is kind of the hottest tables in your database from a change perspective. And if you see something that's really volatile, you want to be a lot more careful about using data compression. You want to be a lot more careful about adding more indexes because it's very write heavy. So instead of guessing, now we know that this customer table is really seeing a lot of updates on. I'd be a lot more careful about that one. Okay, the next one is going to show me fragmentation for all the indexes above a certain size. So when I run this, this shows me that my fragmentation is really low, but some people do kind of a stupid thing in my opinion, and they go in and like rebuild all their indexes every night, whether they need it or not. And that causes all sorts of transaction log activity, and it's very resource intensive and causes problems for availability group replicas. So you don't really want to do that. But at the other end of the spectrum, some people say, oh, you don't need to ever do any index maintenance. And I think that's also a mistake. High fragmentation can cause problems for some kinds of queries. And some people will say, well, with solid state storage, it doesn't matter. And I disagree with that too. So you want to find kind of a happy medium where you're doing index maintenance on certain indexes where it makes a difference. So that's kind of my soapbox about that. But this tells you what's going on, whether what you're doing is working or not. So the next one in the set is showing me which indexes have the most reads. And these are the ones that are most valuable for your select queries. So it shows you seeks and scans and lookups and total reads and total writes and other things like what the fill factor is and whether it's a filtered index. So that's pretty useful. It also tells you whether or not page locks are enabled, because there was an old bug in SQL Server 2005 that had page locks disabled when you created an index with a SQL Server Management Studio GUI. So I find a lot of old databases have that problem, that even though they've been upgraded over the years. So this will help you spot that. The next one does the same thing for writes. So it's ordered by writes. And this helps you find, again, indexes that have lots of writes and 0 reads, like these two right there. And when you run this on a real production database server, you'll probably find quite a few indexes that you might be able to drop, but you also need to be careful that it's not the clustered index or, a foreign key or something you need for other reasons. So be careful about that. The next one is lock weights. And if you're not using RCSI, you're going to have some lock weights, and this will help tell you, and I'm not going to have any here, I'll tell you right now, but this tells you whether you've got row lock weights or page lock weights, and whether you've had lock promotion attempts. And if you're seeing lots of blocking and deadlocking, and this will point you, okay, which table and which index is seeing all these lock weights. And usually the best way to attack that as a starting point is index tuning, dropping indexes that are not being used and adding indexes that are needed. And if you get your index tuned right, your locking and blocking problems usually get much, much better, not to mention everything else runs better. Okay, the next one in the set is UDF statistics just for this database. And since this database is in 150 compatibility mode, it's got automatic scalar UDF inlining turned on, and I don't have any UDFs that are actually being called, any scalar UDFs, and that's good. Now the next one in the set would show you if you had any scalar UDFs that were eligible to be inlined. And there's certain reasons why they can't be inlined that they talk about in the documentation, and this would help you spot that. Okay, the next one in the set is query store options. Query Store is a really valuable feature. Microsoft used to call it the flight data recorder, and it was added in SQL Server 2016, but I find that a lot of people are not using it because they're afraid of it or they don't understand it. And you have to enable it at the database level. It's not turned on by default. So it is turned on here, and it's not using the most optimal settings. It just has the default settings. There's certain things you want to change based on what kind of workload you have. And Erin Stellato from SQL Skills is sort of the world expert on Query Store, and she has a bunch of blog posts on what settings you want to have for different kinds of workloads. And you want to be really careful. If you're using SQL Server 2016 and you're on a really old build of SQL Server 2016, Query Store can cause problems if you have a really heavy ad hoc workload. But if you are on the latest build, SQL Server 2016 SP3, you won't have those kind of problems. And if you're on 2017 or 2019, you'll have even fewer problems. And they added this, there's an emergency shutoff command for Query Store right here. But if you turn on those trace flags that I talked about earlier, and you're on a new enough build of SQL Server, Query Store is not dangerous, and it's really, really useful for spotting problems with query plans that are getting regressions, and you can freeze query plans. And if you're on Enterprise Edition, you can use automatic database tuning, which requires Query Store to be enabled. That can really help with a lot of bad queries. Okay, the next one in the set is input buffer, and this is going to show DBCC input buffer on steroids, basically, for all of your SPIDs. And I only have this one, but on a real database server, it shows you the SPID number and the database number and all this other good stuff, and then the last command that was run on that SPID. And this can help you figure out, what's going on sometimes when things are not running well. And then they added a new feature in 2017 called Resuable Index Rebuild. And in 2019, it also works on index create. So if you got a really big table and you're working on building an index on it and it's causing problems, you can pause it and then resume it later instead of having to start all over again. And this would tell you if you've got any indexes that have that enabled. And I don't. And then here's automatic tuning, and that's that feature that's Enterprise Edition only, and it only works with Query Store enabled, but you can turn that on like I have. Well, no, I don't have it turned on, but if it said desired state and actual state was on, it would be turned on. And what this would do is Query Store then would automatically notice any query plans that had a plan regression where they were using a lot more CPU than they were within the last hour. And if it notices that, it'll go and get the previous plan that was running better and start using that automatically. And then it also goes back and checks to make sure that that new plan is also working well. And it just does this for you automatically. And it works quite well. But again, you have to have Query Store and you have to have Enterprise Edition to use that. And then finally, well, almost finally, this is your last full backups for this database. And it tells you the machine name and the server name and the database name and the recovery model and the uncompressed size and then the compressed size and the compression ratio, because I was using backup compression. And that's a pretty high compression ratio. And if I saw a compression ratio that high, that means I probably have some good data compression opportunities inside of the database. Now, data compression and backup compression are completely separate, but if you've compressed a lot of your indexes with data compression, your backup compression ratio is going to be lower because it's already compressed a different way. And then this tells me that I was using backup checksums, which is good. It's not a copy-only backup. It only took 1 second to back up the database. And here's when the backup finished, and here's where it went. And this is something that's really useful, the backup location. If it's something like this or a UNC path, that usually means that it's a native SQL Server backup. But if it's some weird GUID instead of something like this, that means something evil like Veeam is doing backups outside of SQL Server. And the reason I say it's evil is that, if you have something like Veeam doing its own backups and you're trying to do something like log shipping inside of SQL Server, well, those Veeam backups will break your log shipping chain. And this will help you spot that problem if that kind of thing is happening. So now the final one in the set, which I'm probably actually going to get rid of this query because I already have it in a previous query now. But this shows you the last good check DB for this database. And I had added that a few weeks ago, and then I added the other one earlier in the set that picks it up for all the databases. So I'm probably going to rip this out pretty soon. But that's the complete set of these. And, the magic of this is understanding, what does this mean? Anybody can run these, but understanding the results is the tricky part. But hopefully, I pass on a little bit of information about that. So, if anybody's still there and you're still awake, I can take, any questions you might have. And if you think of a question later, you can email me too.
This is a great session, Glenn. Shall we start with the questions? Okay, so it's a question from, I think, Jerry, maybe out of topic, sorry. How will I know Turbo Boost is enabled in VM? I see only basic clock speeds and CPU Z is not showing it too.
Okay, well, yeah, that is off topic, but I can answer it, I think. VMs don't always show the correct clock speed. Normally they do. I know, like in OCI, which is an environment that I use at work, they just show the base clock speed all the time, regardless of what's happening on the host. So it depends on your hypervisor. But with most hypervisors like VMware, whatever clock speed shows up with CPU Z is the correct clock speed. And if you don't have your power management set correctly, or if Turbo Boost is not enabled in the host BIOS, then you won't be getting Turbo Boost, and it'll show up in the VM with most hypervisors.
Okay. When running this, okay, this is okay. Okay. So the question: when running this, do you run once to gather preliminary data, then free pro cache and review again after X hours and repeat? I don't know if this is probably related to specific DMV.
Well, what I do in real life is I run these most of the time manually and collect some baseline data. And then usually I find a whole bunch of stuff that's wrong. So then I start going in and fixing the things that are wrong. And after you've fixed a few things, it's a good idea to run this again and see what's changed and what you want to work on. And the thing about freeing proc cache, you can do that. I used to do that at NewsGator sometimes because, especially those bad man queries, if the time that the plan went into the cache is all over the place, then it's harder to figure out what is the most costly thing. So I would actually purposely clear the cache periodically just to get the numbers better. But of course, that can cause a little bit of a problem. It's not as big of a deal as it used to be years ago because modern processors are so powerful that recompiling a query plan is not a huge deal, because it used to be, 10, 15 years ago, if you free the entire plan cache, your CPU would spike up to 100% for a little bit as all the plans were getting recompiled. But with modern processors, it's just like a little blip, and I don't worry about it as much. So yeah, I mean, I want to run this once to get baseline, and then as I start making changes, probably run it again to see, okay, what's the situation now? So you'll probably end up running it more than once.
Okay, another question, is there a DMV that shows TVF execution stats?
Table valued function usage stats? Not that I know of. The one that I showed you is just for scalar. And yeah, because they're not as big of a problem. Maybe there is one that you could use, but I don't have it, and I don't know what it is off the top of my head, so.
If anyone has more questions, please feel free to unmute yourself and just ask. I guess question for me would be, I see you sometimes using XP reader log, and sometimes you use DMVs. So I guess at some point Microsoft converts some of the XP procedures into DMVs, right?
Not necessarily. I mean, Microsoft does whatever they feel like doing. I mean, I've got some friends on the product team, and I've convinced them in some cases to add columns to DMVs. And, you know, sometimes I'll ask them, we should do some things. For example, if I have to read from the Windows registry to pick up something, well, that's not going to work with Linux, right? So I've tried to get Microsoft to add DMVs to get that same information with Linux and be able to use the same DMV for Linux or Windows. And so there's some things that I can't get from a DMV, so I have to do things like read from the error log. And the problem with reading from the error log is if you're recycling your error log like a lot of people do, well, when you recycle it, a lot of the stuff that happens when you really start up SQL Server isn't there. So some of the things like the second query in this set that picks up the core counts, you won't get that if somebody's recycled the error log. So if I was in charge, if the product group did whatever I wanted, I would get everything I needed from DMVs and not ever have to use anything else. But I'm not quite that lucky yet.
Got it. How often DBA tools is, I guess, better than your scripts?
Well, the people who wrote that, and I'm blanking on his name now, which kills me. Anyways, there's a guy in the Netherlands who wrote that particular command right here, and I think he's got it set up so that whenever I make a change, he finds out automatically, and they pull down the latest version. So if you install DBA Tools IO and you start using this method, you'll have a copy of my queries, is my understanding of how it works. But there's also another way to just specify a path where my script lives. So if you're worried about that, you could get the latest version of my script and then just point it at where it's located on your machine, and you'd be using the latest version of the code.
Got it. Okay. Is there any preference to use DMVs or query store? They should return the same results, right? Also, is that right that it's easier to retrieve them for certain time interval?
Well, that's actually not 100% right, because DMV queries, that's one thing I didn't actually mention, so that's a good question. When you restart SQL Server, everything from the DMV queries is reset. And if you restart SQL Server, everything in Query Store is still there. So that's a big difference right there. But I think DMV queries are much more versatile because you can get a lot of configuration information and other stuff. And Query Stores focus more on a narrow problem about query execution and regressions, and things of that nature, plan stability problems. So they're really useful for that, but Query Store can't tell you things like you're missing an index or you don't have your instance configured properly. So it's a much more wide-ranging set of things. So you can use both, and you can write queries that use the Query Store information to get a lot of useful information. And that's something I'm probably going to start doing as I convince more people to use Query Store, at Kerber, for example. So that you'll see some queries that use Query Store from me fairly soon.
Neil is saying the guy that you're referring to is probably Andrea Canam.
Yep, that's him.
Or maybe Gianluca Sartori.
No, it was the first guy.
Okay.
Yeah, I should remember because I've drinking a lot of beer with him. So I just
maybe it's time to repeat it. Another question: easier to retrieve high CPU I/O from Query Store for interval of time than DMVs?
Well, yeah, because Query Store, you can set it up to keep track of just what's happened in the last hour, for example. And with most of the DMV queries, they're picking up more cumulative long-term information. And if you want to get clever, which I'm not really that clever in most of these queries, you could set it up to do a delta, collect some information and then wait 10 minutes and collect some more with DMVs, but that's harder to do. So if you've got Query Store configured properly, you can pick up the most recent stuff more easily than you can with DMVs.
Thank you very much.
Glenn, thank you for presentation. Attendees, thank you for attending Los Angeles Data Platform October 2021 session. We'll see you next time.
Yeah, thanks for having me.
Thank you.
Thank you.